Yesterday, what section was it? 6?
It should be 6.4, right?
Yesterday's assignment?
Yesterday was 6.3.
Yeah, that's what we're looking at right now. All right, we're trying to see how we were doing if anybody has a particular question. All right, yes.
I didn't understand like the word problem.
Okay, so what number would you like me to do? 23?
Yes.
All right, let's start with 23. Then I'll put 23. So if you weren't sure about 23, let's take a quick look at it. All right. Let's post it here and let's take a look at it. All right. It says the cost, including a 6.75% sales tax of a digital home theater system with 40-inch high-definition television, is $2,668.75. What was the original cost? All right, so I need everybody. This is a common question on ERBs. I need you to really listen to what I'm saying. All right, when you go buy something, what percent do you have to pay? You have to pay 100%. All right, so I want everybody to write down on their paper right here 100% for the system. All right, that's what I want you to do. And the reason I'm making you write this down is because I want you to understand percentages better. All right, you have to pay 100% for the system. Then you also have to pay what?
6.75.
Yes, you have to pay 6.75% for tax. All right? So what that means is you have to pay what percent altogether? You have to pay, yes, you have to pay 106.75%, and that's going to be for the what? For the system and the what? System and the tax. That's what I need you to understand. 106.75% represents the what? The total bill. All right, I want you to write that down. All right, I need you to pay attention. I need you to understand that. That's on a lot of standardized tests. All right. So do we know what the original cost of the system is?
Yes. No.
No, we do not. So that is X. You with me, Thomas? Now I have to multiply X times what?
X times 1.06.
I'm very proud of you, girl. 1.0675. Well, because 106.75% is the same. Remember, you move the decimal 2 places, and it becomes 1.0675. Do you agree with that now? Because remember, a percent means divided by 100. Right? So take 106.75 divided by 100. That means the decimal moves 2 places to the left. All right? So again, X times 1.0675, that will give me the total bill, and the total bill was $2,668.75. Good job.
That's the end.
All right, I didn't say that was the answer. I said that's how you set up the problem to solve the answer. And now what do I have to do?
You divide.
That is exactly correct. So X is equal to, everybody take your calculator, 2668.75, and divide by 1.0675. How much? Somebody said $2,500. Please check him. $2,500. All right, I'm really happy with you if you knew that. Now, I'm also, again, kind of bragging on some of you guys that are looking up the information. If you didn't know how to solve this problem, you looked it up on the what? The solutions, and tried to see how they did it. All right, that makes you smarter. All right, I don't want you looking up the solution, just write down the solution if you don't know what you're doing. All right, everybody understand me on that? That's an excellent job. Excellent. All right, very good question, by the way, Thomas. Thomas, does that make sense to you now, what I just did up on the board? All right. Yes, sir. 23. I'm glad we could do that one. All right. Diesel, did you have a question from last night? Or are you good?
I'm good.
All right. Does anybody else have a question? All right. That's good news. Let's go ahead and get started with the assignment then for today. Make sure your name's on your homework, please. All right. Let me take a look at it. There we go. Thank you.
Sorry.
Thank you. Don't worry about it. I know you're looking. You know what I'm saying? Good job. Good job. Okay, now, this was what section? Yeah, I think this is 6.3, so today we're doing 6.4. So let's find section 6.4. Oh, yeah. Today we definitely need a calculator. Definitely need a calculator. All right, and this is another really super important section. This is on the SAT a lot. It's on the ACT a lot. It's on the ERBs a lot. All right, very important. All right. And again, we did this last year. All right. Can anybody remember how to figure out the percent of increase or the percent of decrease? Do you remember that? I know it's kind of I know you know we did it. Do you remember?
I remember doing it, but I forgot.
Yeah. So here we go. Let's head the paper real quick, and I'm going to show you. It's really simple. My lesson today is going to be really short and sweet, and I'm going to expect you to do all the problems on your own. All right? So today is section 6-4, page 272, numbers 1 through 24. Now look up, please. I'm going to really try to show you how I remember trying to figure out math, and I couldn't always remember the formulas, but one of my math teachers showed me how you could figure out what the formula is. You can always figure out what this formula is. All right, I'm going to show you what I mean by that. All right, so I want everybody to look up. All right, I'm going to start with 100. All right, and I'm going to go from 100 to 120. What percent increase is that? That is 20% increase. I feel like everybody in here can look at that and say, yeah, that kind of makes sense, right?
Uh-huh.
So you start at 100 and you increase it by what? 20. And so that's a 20% increase. Now, please pay attention now, because this is where I'm trying to show you. Most people forget how to come up with 20%. Come on, Thomas. I mean it now. I want you to listen carefully to me. You listening? You with me? Because, again, most people can't remember the formula. All right? Well, someone tell me what 20% is as a fraction. 20 over 100. Now, here's what I want you to do. I want you to look up here on the board. No, stop and listen. Here is the question. I went from 100 to 120, and I know that's 20%. So the question is now, how did I get 20% from the numbers 100 and 120? What do I do? What did I add?
100 plus 20.
Nope. Only using the numbers 100 and 120. These are the only numbers you have. 120, well, I should say this. The two numbers that I have are 100 and I went to 120. How did I figure out that was 20%? Justice. You subtracted, and then what? And then we, by what? Yes, we divided by 100. But what does 100 stand for, though? We said something last year. With the rule is, it's the change divided by something. Change divided by the...
Amount?
Now, what is 100?
All of it.
The whole.
No. You're misunderstanding me. So these are my two numbers, 100 and 120. So somebody was right. They said Justin was right. He said, well, to get 20, we subtracted, right? So we subtract. Now, what's the denominator? What's the answer that goes in the bottom? 100, right? So where did I get 100 from? No, where did I get 100 from? These are the two numbers I'm using. They're from the problem. So what is this 100 called? Well, we called that something. Yes, very good. Very good. All right, the percent of increase or decrease is the change divided by the original amount. I want everybody to write that down. It's the change divided by the original amount. Now listen, no, don't be lazy right now. You're learning a formula. Don't be lazy. Write out change divided by the original amount. Now, is 120 the original? No, it's where you start. That's what we mean by the original. Now, Thomas, everybody, I want everybody to look up. Eyes up so I can see if you're understanding me. Come on, look up. I'm trying to get you to understand how you learn this formula in 2 weeks when you forget. When you forget the formula, you're going to say to yourself, I'm going to make myself a problem, and I'm going to say, if I start at 100, now why do we pick 100? Because it's the easiest number because we're dealing with percentages, correct? So in a couple weeks, when you forgot what I yelled at you about, you're going to say, I went from 100 to 120, and I know that's what? A 20% increase. Do you understand why that's for sure a 20% increase? Right? 20% means what? 20 out of 100. So how did I get 20 out of 100 with 100 to 120? What did I do? I subtracted them, and then I divided it by the original, or I divided it by 100. Is everybody with me on that? All right? That's how you learn the formula. What? What's 100 and 120 if I subtract those? That's where I got the 20 from. And then the 100 comes from that's exactly correct. So now listen, this is what I'm trying to teach you now. More than anything is how to learn and how to figure things out. I'm sure, 100% sure, that you're not going to remember this formula in 2 or 3 or 4 months. You with me? I am trying to show you how you can remember how to figure out what the formula is. Put your hands down and listen. Again, how do I figure out what the formula is? I'm saying this again because it's so important. I make myself up a number, 100 to 120. I know that's what? A 20% increase. So now I'm asking myself, how did I get 20% from these two numbers? When I know 20% is the same as what? 20 over 100. So the difference between these is what? 20, and the original is 100. So now I know it's the change divided by the original amount. All right? Change divided by the original amount. Is everybody good with that? Now, if I do the change divided by the original amount, you have to remember that's just a what, though? Decimal. And then you move it 2 places to the right, or you multiply by 100. Everybody with me on that? All right? So everybody do this on your calculator now. Do 20 divided by 100. I know. Is that a percent, though, is what I'm trying to show you? No. So you have to move the decimal over 2 spots, or you can say multiply by 100. All right? Now look, Justice, does that make sense to you now? All right? Percent of increase. Increase if it goes up, decrease if it goes what? Down. Do I really care that you put percent of increase or percent of decrease? No, because if you can't tell a number's going up or a number's going down, we're in a lot of trouble. Do you understand that? All right, now I'm getting ready to get started on the problem, so you better be able to take out your calculator and go zip, 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 zip. Here's how you do it. All right, now these better be great questions. Go.
Like when you do the change, is it 20 or is it 100?
Well, what's the change? From 100 to 120.
So it'd be 20.
It'd be 20. You understand what I mean? The change. You went from 100 to 120. You changed by 20. Is that better? Good.
So say when it's decreased and it was 100 to 90.
It would still be a what?
10%.
10%.
So it would be like negative.
So how is that? No. The negative or positive, don't worry about that because you say it's either a what? An increase or a decrease. Now do you understand what I'm saying? I'm not going to say if it goes from 100 to 90, who doesn't know that's a decrease?
Yeah.
I don't have to put that down. If I say what's the percent of increase or decrease and you write 10%, I'm happy. You got it right. You don't have to write increase, right? Because if you can't tell if it's going up or down, we're in a lot of trouble. All right? The number goes up, it's an increase. The number goes down, it's a what? Decrease. The important part is you have to know the formula. Change divided by original amount. And I tried really hard because you're getting older to show you how you learn formulas when you forget them. And that's exactly how you do it. All right? I know that's a 20% increase. So then I figured out, well, how did I get that? I subtracted and divided by the original. Everybody with me? All right. So now, let's see if we can do the first couple, see if I've done a good job. All right, so here we go. Number 1. From 40 to 32. From 40 to 32. All right? So what is the change?
It's decrease.
I'm over here. What's the change? From 40 to 32 is 8. So I want you to write 8 divided by, what's the original amount? 40. Now you do 8 divided by 40 on your calculator and tell me what that is. 0.2. Now it asks for a percent, so 0.2 is what? 20%. Now come on, that was easy. That was easy. Carly, why do you think it turns into a percent, kiddo? Shh. No, look right here. Look at the directions. There you go. I could say what decimal. You with me on that? I could say what fraction. Right? But in this, we're saying percent. All right, here we go. Miss Hulsman, you're up. Number 2. What do I do? Okay, and what did I get? What do I get? Shh, don't help her.
You do 63 minus 53.
63 minus 53. Shh, look up. Look up. Are we doing 63 minus 53?
Yeah.
Where are you?
Oh! 63 minus 56.
Wow, thank you.
And
What is that?
7.
7 or 10, right?
Yeah.
7 divided by what? Shh, don't help her.
63? Or no, 56.
Yes. Wow, let's just say all the numbers, okay? Now, tell me the final answer as a decimal first. Get busy.
And then
Definitely not 8.
you 56 divided by 7.
That's a good mistake.
7 divided okay. 7 divided by 56. So it's 0.125.
Yes, 0.125. And so what percent would that be? Wow, you did so good today. 12.5%. Very good. It's a good thing we didn't make any mistakes on that one. Okay, let's review, just in case anybody's confused. All right? First, 63 minus 56 today is 7 divided by 56. Now, I understand. All right, some of you guys get a little nervous when you take your test. Anytime I ask you about a fraction, you put it in the calculator like you say it. 7 divided by 56. Comes out to be 0.125. And then the decimal changes to percent, 12.5%. What?
So negatives don't really matter, right?
No, I don't really care about the negatives, right? I told you that. If you don't know that it's what? Increasing or decreasing, I got some problems, right? We're going to have to go back to like first grade, all right? and then we'll figure out if you know increasing and decreasing. What? No. I already know what you're going to say. All right, here we go. All right, let me hear someone who can read. Who can read?
Barely.
I can barely.
Justice, thank you. Read.
Okay, on Saturday, Smoothie Central made $1,300 in sales. On Sunday, they made $900 in sales. What is the percent of change from Saturday to Sunday?
Okay, tell me how to do this. So what would I do?
You subtract the first number minus 100.
And what is that?
400.
Okay, and then what am I going to divide by?
The 1,300.
1,300. Thank you very much. What decimal is that?
Big, but
No, just tell me the numbers.
0.307692307.
All right, now of course you don't have to write that all down. Now we're going to say you round to the nearest tenth of a percent. So let's write this as about 30 point what? 8%. 30.8%. If you would have said 30.77%, would I care? No. All right, if you said 31%, I'm just saying you're not listening. Does everybody hear me on this? I'm not marking it wrong. I'm just saying listen, and I won't have to mark it wrong. I said round it to the nearest tenth of a percent. If you're sitting there going, I don't know how to round numbers, what are you talking about? Put your hand up and I'll explain how to round numbers. We can reminisce like back to second grade if you want. What? Of course you can. All right, number 4.
So you do 60 to 75, which is 15. And you do 15 divided by 60, which is 0.25, which is 25.
100% correct, guys. 25%.
Is it my turn?
25%. All right, so there's 25% error there. All right, it's the same formula. All right, Thomas, you want to do the next one?
Wait, what?
You got number 6.
Yes. I've never said
I'm listening to Thomas. You got to read it for me real quick, Thomas.
Measured area 24 square inches. Actual area 22.5 square inches.
So what do I do?
You subtract
And what do I get?
2.5.
Now let me tell you this, because I like your mental math there. So I don't want to discourage you. All right, listen, you really shouldn't be using your calculator on all these. All right, so watch, Thomas. I tell my kids to do 24 minus 22 first. What's that? And then minus 0.5. Yes, you see what I'm showing you now, right? The biggest mistake kids make when they do the subtraction is they do 24 minus 22 and then put the 0.5. You hear me on that, right? Okay, so again, practice your mental math, okay? So now I have 1.5 divided by what, Thomas?
22.5.
What was the original? Yeah, 24. Wait a minute, guys. I did make a mistake on this, I have to say. Yeah, because, listen, for the percent of error, you always divide by the what? The actual. All right, listen to me. I'm not even expecting you to know that. All right, so listen, look up again. Wouldn't it make sense that the actual is what you're dividing by? Right? So let's say, like we were guessing something, how many, like one year we guessed how many jelly beans was in a jar, right?
No, either.
Would it be better that you divide by what you thought it was, or would it be better to divide by what it actually is? What it actually is. All right, and I wasn't even thinking about that, so I want everybody to listen to me on this. Don't, when they do percent, just subtract and divide by the original. You're subtracting and dividing by the what? Actual. Does everybody hear me on that? All right? So I want to go back now. I want to go back. The estimated was what? 60. So instead of doing 15 divided by 60, we should actually do 15 divided by what?
75.
So everybody do 15 divided by 75. Make that correction in your notes now. Yes.
Wait, I was
Yes.
about to- I was
Yep.
asking
Yep.
a
That's
question.
good. No. That's good.
So it's changed by the.
By the actual amount.
You only do that when you do what?
When it's the percent of error. Look right up here.
So for everyone.
I'm not sure what that means for everyone. Come on, Aiden. I'm trying to make you a thinker. Okay, come on, buddy. We're looking at the percent of error. So the percent of error, it's the change divided by the what? Actual. Always. For 4, 5, and 6. That's the question, percent of error. So I wanted to go back and change number 4. We said number 4 should be 15 divided by what? 75, which was 0.2, which is only a 20% error, not a 25% error. Now, for Thomas's, we still did the 1.5, but we have to divide that by the what?
22.
Yeah, by the actual. That's right, which is 22.5. So now, Thomas, when you divide that, what did we get?
I got 0.06.
A bunch of 6s?
And then a 7.
Yeah, but that just means
I rounded it. Rounded it. No, there's a 7 at the end.
6.7%, if you want to write it like that. Now, if those of you guys who are super smart, you would say anytime you see 6s repeat, it's just 6 2/3%. All right? I don't care how you write it. I'm just saying. You should know when there's a string of 6s, it's 2/3. All right? If you don't like that, just make it, hey, it's about 6.7%. All right? So here we go. Go.
Fine. Okay. The estimate for the amount of rain made is in one part of Texas, 5.6 inches. The actual rainfall is 2.4 inches. What was the percent error of the estimate for the error?
Okay, so,
you got a minus
yes,
2.4 and 5.6.
and got
And you get 3.2.
3.2.
3.2 divided by 5.6. What's the error?
We said we always divide by the actual.
So 2.4.
Divide by 2.4. Agreed?
We get 1.2.
So that's the same as,
1.
no. 1.3 repeated. What percent is that? Yeah, 133. Now, if you want, I really would appreciate if you'd say 133 and 1/3%, or you can say 133.3%. Either one of those is perfectly fine. You understand that or not? Come on.
Are you going to put one of those on the test?
I haven't even made the test up yet. All right? You should know those. All right? You have a calculator. I'm expecting you to do a little better with the calculator. Understand repeated numbers. All right? Is everybody good? All right. Now what I want you to do is try your best on 7 through 24. On 7 through 24. Set up the fraction and then let the calculator do the work. Write the decimal and then write the percent. Rather than I'm not interested in you just writing down a bunch of answers. Write the fraction, write the decimal, and then write the percent. You're welcome. Because you're a good boy. Most of the time.
I lost it. I couldn't find it.
What am I going to do with it?